Hi everyone, this is Miss S from Excelsior Charter Schools, and today we're going to be doing geometry lessons 1-3 and 1-4. We have lots of vocabulary to get through in this lesson, so let's go ahead and get started. So we're going to begin with point, space, line, and collinear points. A point is simply a location. A point doesn't have any size, and it is usually represented as just a small dot. It's usually named with a capital letter, so we could call this point A. Any figures we're going to discuss in geometry are really just a set of points. So space is defined as the set of all points, and we usually won't use this too much other than to say that there's a figure in space. So as far as lines go, you can think of a line as a series of points that extend in two opposite directions. So through point A here, we might have a line like this. Lines always have arrows on both sides, and it has to have arrows on both sides if it's a line, because it goes forever in both directions. When we're naming lines, we usually name it with two letters. So we'd put another point on this line here. We'd call this B, and we could label this line AB. And you would label it just like this. In geometry, you'll see that a lot. You could also label this as line with a lowercase letter. We could call this line M, something like that, and that would be acceptable. So collinear points are exactly what it sounds like. Linear, of course, means line, and co would be like the same. So they're points that lie on the same line. So points A and points B here would be collinear because they both lie on the same line. If I put another point out here, we'll call this point C. Point C would not be collinear to A and B because it would not lie on the same line. Okay, so moving on now to plane and coplanar. Now, a plane in geometry is actually invisible. It's a flat surface that has no thickness. So it can contain all kinds of lines. It extends without end in all directions. So here is an example of a plane. Notice it goes in all directions here, and planes can go however you want. If you're looking around the room you're in, you will probably see a table of some kind. The top of the table could be a plane. You could also put a plane coming down the side of the table, like from the ceiling to the floor. That could be a plane. Planes can go diagonally through the table in any direction you want. So planes can go in any way. And coplanar points, of course, are points on the same plane. So in this case, we might have over here, we might have point D on the plane, we might have point on the plane, and we might have point F over here on the plane. But over here off the plane, we might have point G. It might be up above the plane as the plane extends forever, so something like that. So if you were looking at the top of a table, let's say that is the plane. Let's say you have something resting on the ground. It would not be coplanar to that tabletop plane. For example, you want to name each plane with at least 3 letters. So if I wanted to name the plane that's along the bottom, I could name it HBC, I could name it GCB, I could name it any of those 3 letters, and that would name that plane. And if I use that plane here on the bottom, and I wanted to know which point was not coplanar, I could pick any of the ones that are along the top, A, E, F, or D, because none of those would be along the bottom plane. So I hope that you understand that one. All right, we're going to move along. This word is called postulate or axiom. Here in America, we use postulate. In a lot of other countries, they use the word axiom, but they mean the same thing. It's simply an accepted statement of fact. In science, you may have used a scientific method and you've heard the difference between a theory and a law. These are basically the theories. The postulates that you're going to learn in geometry are the theories. So we're actually going to learn the first 4 postulates in geometry now. It is not important that you remember the numbers of the postulates. It is important that you remember what they say. So in your geometry notebook, you're going to want to make sure that you write these down. So postulate 1-1 says that through any 2 points, there is exactly one line. So in order to make a line, you need 2 points. Postulate 1-2 says that if 2 lines intersect, then they intersect at exactly 1 point. So you'll notice here that they have line AE and line BD, and that they intersect at point C. So if you think about that, anytime 2 lines cross, remember lines are always straight, they're never curved. So anytime 2 lines cross, they always cross in exactly one spot. So 1-3 says that if 2 distinct planes intersect, their intersection becomes a line. So you can kind of think about that actually if we go back here to our cube. What you'll notice is that where the 2 planes intersect, if I do this plane right here in yellow, which is on the right hand side, and then I do this plane right here in red along the top, what you'll notice is that they overlap right here, and that forms a line. So that's what that postulate says. If 2 planes intersect, they intersect in one line. If 2 lines intersect, they intersect in a point. 2 planes intersect, they intersect at a line. And then the fourth one, through any 3 non-collinear points, there exists exactly 1 plane. So in order to make a line, you need 2 points. And in order to make a plane, you need 3 points, 3 non-collinear. And those are all the postulates. All right, so we're going to move on to segments and rays. So as you have learned, a line, of course, goes in both directions forever. But if I wanted to just take out part of it, if I wanted to cut it from like here to here, for example, that would just be a part of that line. And that part would be called a segment. So a segment is just part of a line that consists of 2 endpoints and all the points between them. So a segment is always ended with 2 points. And you always call that segment, you can call it AB or you can call it BA, either way you want to use that. And when you write it down, you will write it, if you write it AB with just a line without arrows. And that's how you note that it's a part of a line, it's a segment. So a ray is part of a line that goes from 1 point and it goes forever in the other direction. So we'd have A here, and let's say we have, point B there. This could be ray AB, and it always needs to start with the endpoint, and it will have 1 arrow. This cannot be ray BA because it doesn't start with point B. So that's segments and rays. So we move on to parallel and skew lines. So here's an example of parallel lines, and parallel lines are coplanar lines. They're on the same plane that do not intersect. So these lines will never intersect. And if you Google parallel lines, you'll find examples of them all over the place. You'll probably find some wherever it is that you're sitting right now. If you have blinds on your windows, those are parallel lines more than likely. The top and bottom of a whiteboard or a television set, the left and right side of a door, those are all parallel lines, because if they aren't, that door's not going to be able to open and close very well. So parallel lines. And then for skew lines are non-coplanar, and they also do not intersect. So this green line here going across the top back there of this box, and the red line coming through the front part here. Those lines will never ever cross, of course, just like parallel lines will never cross, but skew lines are not on the same plane. So that's parallel and skew lines. You don't see skew lines too often in geometry, but you do see parallel a lot. So for our last one, we have planes, and I wish I found this box earlier, but that's okay. So parallel planes are 2 surfaces, so to speak, of this cube that are going to run parallel to each other. So for example, the top, AEBF, this one here, would run parallel to the bottom, GHDC. So it's like if you had a box in front of you, the top and the bottom would be parallel to each other. They're going to run the same directions, but they're never going to touch. So good luck, everybody. I hope you guys do great.